Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 31 in our legendary new and improved Arduino tutorial series. What I need you guys to do is pour yourself a nice big mug of iced coffee. No sugar, just strong black coffee poured over ice. Don't use any of that little sweetener packets. No vodka or other alcohol, just straight coffee over ice. Caffeine is what fuels the world of engineering. I also need you to get out your most excellent eLego Super Starter Kit. If you don't have one, check the link in the description. $35 off of Amazon. Has the Arduino and a boatload of components. I use this kit in all of this series of lessons, and seriously, it does make life a little easier if you have exactly the same hardware I have. Makes it easier to play along at home. Okay, I gave you a homework assignment in lesson number 30. How many of you did it? Nobody? Nobody did the homework? Not one? Leave a comment down below and tell me that you did your homework. But I'm going to do it along with you. And what the assignment was to take the servo in the eLego kit and to get the photoresistor and a 5K resistor and to build a graphical display that shows the conditions outside or the conditions around you. And so what you want to do, you want to have a little dial, and if it's very sunny, you want the servo to point towards sunshine, cloudy, and then night. And so this thing moves based on how much light is around it. So you see why you need the photosensor. If you don't know how to use the photoresistor, go back to lesson 25 and 26 where I cover it in most gory detail. All right, so I'm going to go kind of fast because if you can't keep up, you can go back to lesson number 25 or lesson number 26. So let's get going here. First thing I'm going to do is hook up the servo. And what we need is, if you remember from lesson number 30, that the red wire, let me get the red wire. The red wire is going to go to 5 volts on the Arduino. So I come up here to the 5-volt pin. Okay, now I've got 5 volts. Now I want ground. Well, the ground, if I am not mistaken, I always look so that I don't make a mistake. Ground is brown. Brown is ground. So I'm going to come to the brown wire coming off of the servo, the brown wire, and that is going to go to my GND, which is right there. And now my control wire, okay, so I've got 5 volts and I've got ground on the red and the brown. And now what do I need? I need the control line. The control line is the orange line. Okay, so I got the control line, and then that is going to come over to pin 9. I think, if I'm not mistaken, you need to use a pin with a squiggly for this, so make sure that you're using a suitable pin with a squiggly. All right, now we have the servo hooked up. Now we're going to build the photosensor. Remember, for the photosensor to work, it needs to be pointing towards the light. I'm going to put it between column 50. Let's see. I'm going to put it in column between column 5 and column 10. As such. Okay, that's in there. Nice and neat. Now I have my 5K series resistor. In order to create a voltage divider, I will put that from 10 to 15. And notice that the photoresistor and the normal resistor share a common column, and that connects them together. Now what I need is I need to take the top leg of the photo detector, which I have in column 5, and I'm going to bring that over to, oh my goodness, I need 5 volts on that. And so what I'm going to have to do is, since I've only got one 5-volt connector there, I'm going to have to bring the power from the Arduino over to row 2 on the PC board. By bringing it to row 2 on the PC board, Okay, can you see that? Row 2. That is going to create a positive rail. Now, anything that plugs into that will be connected to 5 volts. And so now I will jumper from there back over to the servo. And so now, once again, the servo has power. Okay, but the servo has power not directly from the Arduino, but the Arduino is powering up row 2 on the breadboard. And now I can get power for the photodetector off of row 2 as well. And I will do it like that. Okay, so just to make sure that you see, the left leg of the photodetector is connected to this blue wire, which then goes to row 2. So the photodetector should now have power. I need to ground the photodetector, so I will come over. I need to ground the resistor. So the right leg of the resistor, okay, do you see that right leg of the resistor? That is in pin 15. I'm going to bring it over to GND. GND. Okay, you see that? GND on the Arduino. All right, so I have my photodetector set up. Now I just need to read from the voltage divider, which is this connecting pin. Okay, so do you see that pin that connects the photodetector to the resistor? They're in a common column. In column 10, well, I'm also putting this white wire in that column 10, and then I am bringing it over to A4, pin A4. So I will read the photodetector from pin A4. So first thing we need to do is kind of figure out what is going on with the photodetector. So my first coding will be centered around the photodetector. So I need to come over here like this one, I believe, and get this set up. So let's get the photodetector working. Remember, in order to make this thing work, we have to do math. And yes, we will do the math today. But before we do the math, we need to get some readings off the photodetector. So how do we get the photodetector to work? Well, we're going to read a light val. You know how strong the light is. We're going to read the light val off of this thing. So we're going to need a variable light val. We don't put anything in that because we'll be reading that from this circuit. And then we have an int. We have light pin. That's the pin that it's connected to. And I do believe that we connected light pin to A4. So light pin is equal to A4, like that. Is it really going to be that simple? I think it might be that simple. All right, we come down here and we need to turn on our serial monitor. So we will do a serial.begin. Baud rate, trusty old 9600. Now we can use the serial monitor. And in our loop, it is going to be relatively simple. We're going to read that light pin. So we are going to do light val is going to be equal to a, let's see, how do we want to do this? Analog read. So we're going to analog read from where? Light pin. Okay. And what did we forget to do that would have ruined everything? If I'm going to use a pin, I have to do a pin mode. Pin mode, what pin? Light pin. And then what is it? It's an input because I am going to read from it. Now I need to see what I have. And so I'm going to do serial.println, and then I'm going to print light val like that. And now I'm going to delay, and I'm going to be good in delay by dt, delay time. And then I will come up here and create a variable for that, int delay time, and I'm going to say equal to, let's say, 250. That should be good. So let's go ahead and run this and see if this thing is going to work. Everyone, please hold your breath. Oh. it looks like it's going to work. I need to come over here where you will be able to see the serial monitor, and I need to try to fire open that serial monitor. Where is that thing? Okay, there it goes. Okay, do you see that? So let me turn all the lights on, because these are the two values that we really have to have. We have to have what is the value when the lights are all the way on. And what you can see is, let me get some fresh paper here. And I'm going to kind of move this because I'm going to start writing down some very important values. Okay, the very important value that I'm going to write down is that when the lights are fully on, when I'm fully bright, so the lights are fully on, what am I reading? Well, I was seeing, like, I think I'm going to call it about 780. I'm reading a value of 780. So I need to know where the lights are all the way on is 780, and then where the lights are all the way off. And I'm going to have to turn the lights off. Pardon me. Starting with the overhead lights. Do you see how it already went down? Okay. And now turning off the studio lights. Okay. Sitting here in the dark now, we are reading a very nicely dark, I'm going to call it like 150. Okay, we'll turn the lights back on. All right. And now I'm going to, now that I have those two values, we have to do our math. So I'm going to come back over here so you can watch. Guys, understand that what you want is when it's dark, you want it all the way to the left, pointing at something like a moon or darkness. And then when it's all the way bright, you want it coming over here, pointing to sunshine. And so in order for that to work, you have to do your math. And so this is what we have found. We have found that when the lights are all the, and this is going to be linear, so we're going to need a line. So to do a line, we need how many points? We need 2 points. Okay. Now, the independent variable on the line, let's go ahead and kind of draw what we are going to do for a line. Okay, we're going to take the value that we read and we're going to turn it into the value that we write. Well, what is it that we read? What variable are we reading? We're reading light val. Light val. Okay, that's the number that is coming off the photodetector. Then, what do we want to turn light val into? We want to turn light val into an angle. Okay, we want to turn light val into an angle. Well, it looks like if we were going to create a scale here, light val, it looks like would go from 0 to 1023. So we would say, like this would be 250, 500, 750, 1,000, and then 1023 would be right about there, because this is an analog read, and analog reads go from 0 to 1023. So this axis here would be 250, 500, 750, and 1,000. Why is that? Because analog read on the Arduino reads a value between 0 and 1023. So that's our horizontal axis. On angle, what can we do with the servo? We can go from 0 to 180. But if you remember on my sensor, on my particular one, it won't go to 180, it'll just go to 160. So if yours will go to 180, use 180. If yours only goes to 160, use 160. But the angle would go from 0 to, let's say, 160. So I'm going to call this 100 and call this 200, and then 160 would be right about there. All right, now in order to make a line, we need 2 points. Well, what do we know? We know that the brightest number that we saw, okay, or the highest number that we saw when the lights were completely out, that highest number that we read was 780. And that is the x value because that's the value that you read. That's the independent variable. And so if we're all the way in the dark, where do we want the sensor to read? We want the sensor to read over here all the way to the left, which is going to be 180, but for mine I'm going to use 160, right? Because my servo can't go all the way to 180. It can just go to 160. So if I read 780 off the sensor, I want to go to an angle of 160. I have how many points? I have 1 point. I need another point. Well, what was the other point? When the lights were all the way off, it was 150. Okay, I think I did that backwards. I hope you guys were screaming at me, right? That first one that we did was when the lights were all the way on, it was 780, and in that case, lights all the way on, I want to be at an angle of 0, and then lights all the way off was 150, and I want that to be at the angle 160. All right, does that make sense? And let me just explain it. You're going to read a number between 0 and 1023. You want to change that into a number between 0 and 160. To do that, you need 2 points. From those 2 points, you can create your line. When the lights are all the way on, I was reading 780. When the lights were all the way off, I was reading 150. All right, now we got to create the equation of the line. The first thing that you have to do is calculate the slope. M is equal to, and I guess I should say, your dial could be opposite. You could say 780 and 160, and then you could say 150 and 0. You could use different points, but the performance just has to match the dial that you created. So what is M? M in math class is y2 minus y1 over x2 minus x1. Do you remember that? Well, we're not doing x's and y's. What are we doing? We'll use our variables. We are using angle 2 minus angle 1 over light val 2 minus light val 1. Okay, now we can put our numbers in. So here are our 2 points. Which one is angle? It's the second one. Okay, so I'm going to say it's the second number in the pair of numbers. So it's 160 minus 0. Okay, angle 2 minus angle 1 over what? x2, which is 150, x2 minus x1, which is what? 780. All right. Then this comes out to be a negative slope. It's 160 over, and I never do math in my head on live TV. It's 780 minus 150, or 150 minus 780. It is minus 630. And so we can simplify this slope to minus 16 over 63, but I won't try to reduce that anymore. We can put that in the Arduino. So M is equal to minus 16 over 63. All right, so I have the slope of the line, and in fact I can kind of already draw the line because I know that when I'm at 780, which would be right about here, I want to have 0. So this is the point 780, 0. And then when I'm at 150, which would be right about here, I want to be at 160, which would be right there. So this is the point 150, 160. And then I want a line between there, like that. Okay? So it's the point 150, 160. It's the point 780. And now I have the slope of the line is minus 16 over 63. Now what's the point slope form of a line? The point slope form of the line is y minus y1 is equal to m with parentheses x minus x1. So now what do we use? Well, we use light val. So I'm going to have light val, I'll just abbreviate it like that, light val minus light val 1 is equal to m, no, that's angle. Angle is y. Okay, sorry. Angle minus angle 1 is equal to m onto light val minus light val 1. Light val minus light val 1. Now I can start putting the numbers in. Angle minus angle 1. Well, what is angle 1? This is the first point. Angle 1 is 0. So that's kind of nice. Angle minus 0 is equal to m. What is m? It was minus 16 over 63. Minus 16 over 63 times what? Light val, which is still light val, minus light val 1, which is 780. Okay. 0 goes away, so I'm left with angle is equal to minus 16 over 63 times light val, and this is the light val that you're going to read, minus, I'm just going to leave those, I'm not going to try to come up with a number, I'll just say it's a minus and a minus, make a plus, and that's going to be 16 times 780 over 63. So understand what's happening. If I put this equation into Arduino, I will measure a light val, which I call LV, and then I will multiply it by minus 16 over 63, and then I will add 16 times 780 over 63. And what that will do is that will create the right angle, the correct angle, so that when it's very bright in the room, the servo will point to the sunshine on the dial, and when it's very dim in the room, it will point to the moon, and it will move smoothly in between. Guys, I'm sorry I made a few mistakes in here, but you just can't do something like this without understanding the math. And so now let's go in and start programming this. I will bring this back over here, and now we will have to do some coding. But I'm going to keep this handy equation here where you can see it. And now we're going to start coding this thing up. Want to really make sure that you see that equation. Okay, now we're going to start needing some additional variables, right? We are going to need some additional variables. And the first thing that we are going to need to do is we're going to need to make the servo work. And if you watch lesson 30, you know that you have to do a pound include, and you have to include your servo library so that Arduino knows how to parse your commands. So you have kind of the open triangular bracket, and you are not seeing me. So sorry, so sorry. I will come over here to this one is pretty good. Okay, I believe that one's going to work. So you've got to include your servo library, which is servo.h. That way Arduino will understand your servo commands, load the library. Now you need to come down here. What is that nonsense? You need to come down here in your void setup, and now you have another, now you have to do a few more things. I'm sorry, before you do that, up here above the void setup, you still need to create your servo object. Again, this is all explained in lesson number 30. So you could say servo, my servo. Now you have a servo object. Okay, what will you need to do? You also have a position, and what we called that was, in our math, we called that our angle. All right, and where are we going to get angle from? We're going to calculate it. We're going to read light val, right? We're going to read light val. Let me get further out of your way. We are going to read light val, and we are going to calculate angle. So we need angle. Do we need any other pins? We do need to attach the servo. So we've done the pin mode for the light pin for our read, but we now need to attach the servo. So we say my servo, okay, and then what do I want to do? Dot attach. And then where am I attaching it? I'm attaching it to servo pin, which I have not defined yet. So I need to come up here, and I need to say, I need to have int, and then servo pin. And where did we connect the servo? I have forgotten already. We connected it to A4. So this is going to be A4. One of our analog pins. And then if we have another pin, we have to do another what? We have to do another pin mode. What is the pin? Servo pin. And what is it? It is an input. Okay. Oh my, light pin. I'm surprised this worked earlier. That should have been an output. Okay. Why did I make light pin? Why on earth did I make light pin an input? I am all messed up. Light pin is an input. Oh my, I just had a glitch. Light pin is an input because we read from it. Servo pin we're writing to, and so it is an output. And oh man, you guys should have been screaming at me. I had a mental glitch there. Servo pin is where the servo is, and that was 9. Okay, better have a little more coffee here. Okay. So now we've done our pin modes. We have our servo pin. Our servo pin is attached. We have read down here from our earlier code, we have read light val. Well, after we read light val, what do we want to do? After we read light val, we want to take light val and we want to turn it into angle based on the math. And so let me come back over here. And so I need to now calculate what angle is. So we're going to say angle. And let me get this really where you can see it. We're going to say angle. And I used a little a, I believe. Angle is equal to, what is it? Minus 16. And I am going to be using floating point numbers here to make sure that we don't round to 0. So you need to put minus 16 point divided by 63 point. Okay, close my parentheses. And then times what? Times light val, which was the variable that we used up here. Light val. And we just wrote it as LV to just kind of abbreviate, but the variable we're using is light val. And then what do? I add the number 16 point times 780 point divided by 63 point. Okay, so that will take the light val that we just read and it will change it to angle. Okay, so then what we want to do is we have to send that to the servo. So now we are going to say my servo dot write, and what do we want to write? We want to write angle. So that will then tell the servo to go to the number, to the position angle. All right, let's see if we can get this thing set up. And in order to see it a little better, I have made, let me show you, I have made this slick little dial here. So we will get the servo and we will put this little arrow on it like thus. Okay. And now we are going to get my most beautiful dial like here. And actually, it probably goes this way. I hope it goes this way. Okay, like that. And I need to put something there to try to secure it a little better so that this thing isn't flapping around. I don't want to tape it down because I don't know yet for sure that I'm oriented correctly. Okay, so that looks pretty good. Okay, so like that. All right, now what I need to do is I need to come back over here and I need to download this code as we all hold our breath. Oh, what did I do? My servo. Oh, do you see this? You guys were not holding your breath, were you? I did not put the semicolon there. I hope you guys were yelling at me when I did that. Let's try it again. Okay, it downloaded. All right. And let's see if we can get this up here. All right. Ah, you know what I think? I think this is going the wrong way. Okay, maybe, perhaps, we should make it go this way. So let's see where dark is. Okay, dark is like that. All right, we have our orientation right now, I think. The frustrating thing with this is we are going to, very few things in life cannot be solved with tape. So I think we know our orientation, so I'm going to try to tape this down. Okay, so now let's look at this. And I'm going to turn the studio lights back on. Let's see, and just to kind of make sure, I'm going to put a print statement in here so I can kind of see what the angle is that, or I'm going to look at the, oh, I already put the light valve. I'm gonna, okay, there it is. Okay, light valve is 780, so I think my orientation needed to be, that is why I did not want to tape it down. You see why I was in engineering and not art class. Okay. So now let's put this back on like that. And maybe move this up a little bit like that. Okay, so that is saying bright sunshiny day. Okay. So now let's start turning the lights off. All right. So I turn that off. Oh, look, it's a little darker. Oh, look, it's becoming a cloudy day. And then let's come over here and let's go like that. Oh, it's becoming an even cloudier day. And look at that. It comes all the way over, and you can see that it is almost nighttime. And then here I can get it to go all the way to nighttime. So we have nighttime. If I get a little bit of light from the monitor, you can see it starts coming up. If I turn the light on, it starts coming to really bright because there's a light just right above it. I think if I turn the other lights on, okay, so it shows a little bit more cloudy, full light. Okay, boom. So you can see that the math actually worked. Okay, the math actually worked. And in fact, let me print out angle just so that you can kind of see a little better. Let me take this, Control copy, come down here, Control V. Instead of printing out light valve, I'll print out angle. I didn't do it though. Angle download it again. Okay, so the thing that you see is that, man, I hope that it came across. The problem that you have with the Arduino, you're making readings from one set of devices like sensors and then mapping those values onto output devices. And so when you read from an analog pin, you're going to read between 0 and 1023. For this case, for our particular case, we were reading between 150 and 780. And so what you got to do is you got to go through the math to map 150 to 780 onto, like 0 to 160 in my case. And so you can see that when it's full bright, I have it at 10 degrees is what it is saying, that it wants an angle of 10 degrees. And then when I go to the darkness, it's creating an angle of about 167. And that's really just pretty much exactly how we wanted it to behave. And so it is mapping those readings from the photosensor, and it is mapping them onto the servo. Now, if you're watching this, you can see that this thing has been just a little bit glitchy, right? Like the motion is not real smooth. It's a little bit glitchy. Again, that's why if you use one of these better servos, you'll get a lot better results. I hope you guys made it through the math with me. I made a few mistakes as I was going through it, but I hope in the end it became clear what we were doing. Let me know, did anybody do the math before I showed you how to do the math? Did you guys do the math with me, or when you saw that I was going to do math, did you just shut the video off? Because I know that a lot of people, it's like they don't want to do the math. And the thing is, at the end of the day, somebody has to know how to do the math. And the fact I know how to do it, well, I'm an old guy, I'm not going to be around forever. You guys need to learn how to use the math, because these projects, you really can't do things like this without having the math. Okay, guys. Would really like to hear your comments down below. Would like to know, did you do the project? Did you do it without watching, or did you do it after you watched? Did you do it like me? Did you do it differently? Did you have a better way of doing it? I'd really love to hear from you down below. Also, think about giving us a thumbs up. Think about subscribing to the channel. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.